Hi, everyone. Thanks so much for joining me today. My name is Dr. Matt Bertin, and I'm an assistant professor in the Department of Biomedical and Pharmaceutical Sciences here at the University of Rhode Island. And what I'd like to show you today is a process for finding potential medicines from natural products, like this fungus here. So it may not look like your typical fungus, like a mushroom that you're used to seeing, but believe it or not, this is a fungus. It is called chaga. Its scientific name is Anaerotis obliquus. And what is so cool about this fungus is that it is endemic to the Northeast. That means it's only found in the Northeast part of the United States. So Rhode Island, New Hampshire, Maine. And what this fungus does is it grows on birch trees. And it's basically like a parasite. And it grows on the birch trees and it takes nutrients from the birch trees and it eventually will kill those birch trees. Now, why are we interested in chaga? We're interested in it because it has several medicinal compounds in it. So it has chemicals inside of it that we think we could potentially turn into drugs. And I'm going to show you the process for how you go from something like this that looks almost like a log to something like this, a pure powder, a pure potential drug. Okay, so how do we start this? The first thing we're going to do is we're going to grind up this chaga specimen. And so I'm going to go into the fume hood here. And so this is like, for me, like a cooking show. And so some of this I've already done. So before I start, I just want to say on also called PPE, I'm going to be wearing gloves. I am wearing my laboratory coat. And I am wearing safety glasses, as you can see here, and I am wearing a face covering. So, all right. So before we started today, I ground this up. So what I did was I chopped it with a knife, and then I put it in this mortar and pestle here, and then I ground it. And so we have this very nice, fine powder. I'm just going to move this out of the way. The first thing I'm going to do is pour this powder into my extraction vessel. So I'm just going to gently pour the powder in. The reason I'm working in the hood is because there's dust and vapor that comes off of this, and I don't breathe it in. So I want to make sure that I'm working in a hood where there's a vacuum that's sucking up those fumes. Okay, so my ground chaga is now in my extraction vessel. I have a solvent. This is a liquid solvent. It's called methanol. I'm going to pour the methanol onto the chaga, and the methanol is going to pull out all the chemicals that are in the chaga. It's going to dissolve them. So let's do that first. Okay, so I poured the methanol over the chaga, and I let this sit. And I would let this sit probably for a day, maybe 24 hours, maybe even 48 hours. And the chemicals in that powder were going to leach out into the methanol. And so, because we don't have 24 hours to wait, I did this the other day. And this is my final extract right here. It's this nice, beautiful golden color. And you can see I wrote chaga extract on it. So this is the first step in going from a plant, going from a fungus, going from any specimen that you're interested in, going from that natural specimen and ending up with a pure potential drug. The first step is the extraction. So now I have my extract. Now, there's a problem here that I need to solve. The extract is very, very complex. It has many, many types of molecules in it. It has fats, it has sterols, it has hydrocarbons. And these fats and hydrocarbons, they can clog up the analytical equipment that we're going to use for our final purification to get this nice white substance here. So I need to perform a preparation step. I need to do something called chromatography. And what I'm going to do is I'm going to take this extract and I'm going to pour it over this column. And what's going to happen is that the column, this white powder, it's going to hold on to the compounds that I don't want. Those compounds are going to stick on this white powder. The compounds that I do want are going to pass through the column and they're going to come out into this vial. And so I will be leaving the fats and the hydrocarbons that I don't want on the column. And I will be eluting the compounds that I do want into the liquid portion. So I'm going to take you through this type of chromatography, and it's pretty fun. So let's see if I can do it. The first thing I need to do is grab my solvent. Again, I'm using methanol. So you can't just put the extract right onto the column. You have to do what's called a conditioning step. So I need to wet the column with methanol. So I'm going to put about 6 milliliters of methanol onto. And then what I'm going to do is take this rubber bulb and apply just a little bit of pressure on top and pass that liquid over the column. You see it dripping out? All right, so I'm going to do that more times. What's important is that I don't let the column run dry. I have to keep it wet. So we did 1. And we're going to do. So here's our second. Just very gentle. And you can see those individual droplets of solvent coming out. All right, that's 2. And we just need to do 1 more. So this is the last washing step. Okay, I just have to reach over here really quick to grab a pipette. And now I'm going to transfer some of this very dark golden colored extract onto this column. Okay, so what I want to do is now put my collection vessel underneath, because these are the compounds that I want to analyze. So now you can see that golden color up at the top, and I'm going to just put a little bit of pressure, and I'm going to add a little bit more of that methanol on top. we'll see a pale yellow color instead of that dark yellow color, because the dark yellow are all the fats and hydrocarbons that I don't want. Okay, and now I'm just going to put pressure again, and let's see what we get. So far, so good. Okay. So now I have my sample prepared. And can I show you the difference? Hopefully you can see. You have that dark yellow initial extract, and we have this lighter yellow prepared sample. So the fats are in this one, but the fats didn't make it into this one. They're stuck here on this column. So, okay, what I have to do next is transfer some of this prepared sample into a special vial. And this special vial is going to go into an instrument called an high performance liquid chromatography system. So that's a mouthful. But what this system is going to do is it has a special column in it. It's a much better column than this one. It's a column that can separate out the individual molecules so that I can isolate this pure substance. And then we'll talk about this substance at the end of this lesson. So I'm going to walk over to the HPLC, and I'm going to show you how that machine works. So now we're at the HPLC machine. What we're going to do is we're going to pass solvents over this sample and then over this specialized column here. And that specialized column is going to be able to separate out all the individual pure molecules. So this part's pretty fun. So I take my sample, and what's really cool about this is suck up some of the liquid and send it into the system. That liquid, which is a mixture of chemicals, is going to get put onto, again, that special column, which is then going to separate out those molecules and allow us to collect one at a time pure drugs. Okay, so I put my sample into a spot, and I have to just go over to the machine really quick and press run. And this takes just a few minutes, actually just a few seconds. So it's just taking a second to boot up. And so I really want you guys to be looking at the machine and watch. And you can see the auto sampler where you put your samples is moving. There's the needle. It's injecting into the sample. Pulling. And now it injected it into the system. So the chromatography step here might be a little bit complicated for the lesson today, so we're not going to focus too much on it. I just want you to remember that this is the final step. So we fungus. We ground the fungus up, and we poured solvents on it to extract. We had two prepared. We passed the sample over that column so that we stuck those sticky fat hydrocarbons on the column. We brought it over to this HPLC, and we are now separating out, and we can isolate those individual compounds. So this takes about an hour, which again, we don't quite have that time. So I'm going to head back to the lab bench and show you the final product. So again, this is our white powder. So what I think is so fun about this is that we went from this fungus here that looks almost like a log you'd throw on a fire to this rich golden extract to this paler yellow prepared sample. And after it comes out of the HPLC, it's in a liquid form, and then we dry it, and now we have this beautiful white powder. And this is called anatidiol, is the name of the compound. Why is it called anatidiol? It's called anatidiol because it's a chemical that comes from Anabatis. That's the scientific name of the fungus. So Anabatis, anatidiol. So scientists, they're not that creative, or maybe we are sometimes creative. We normally name compounds after the plant or the fungus that they come from. Okay, and so a final look here at how pure and beautiful this molecule is in its crystal form. So I'm going to show you a close-up of it. And I think it looks really cool here. You can see these individual crystals. I'm having a little trouble. There we go, steady. Yeah, there are some. There are some nice ones. And so again, you can see we've gone from that kind of lumpy wood-looking fungus to these nice, pure crystal molecules. I'm not a pro yet with this camera, but I think you can see them. I'm going to try to get one more look here. There we go. How cool is that? Look at that. You can see the crystals right there. So that's a great sign of purity. So we did a good job. So to wrap up, this is procedures that are done in medicinal chemistry and what's called natural products research. Over 50% of the drugs that we use in the clinic today come from natural products. What are some famous ones? Aspirin, an anti-cancer drug called Taxol, and many, many antibiotics that we use in the clinic. Also antiviral compounds. So it's very important to look for drugs from these natural sources. And that's a big part of what we do here in the URI College of Pharmacy. So I can't thank you enough for joining me today, and I would be happy to answer any questions that you have about the process or about other things that we do here in the College of Pharmacy.
What are some examples of jobs where you'll be doing this type of work?
What a great question. Yes, how could you have a career in natural products? A career in this type of work can be very diverse and very broad. So for instance, there are scientists who work to really, really develop these drugs to go into the clinic. So these are going to be chemists and pharmacologists. So these are folks who try to see how the drugs work in your body. And these folks might work at large pharma companies like Merck and like Pfizer. So they have to do chemistry to figure out what the drugs look like. And then they have to do more chemistry to make the drug perfect for the patient, or as close to perfect as possible. And then they need to be able to evaluate how the drug works in the patient. That's more on the pharmacologist side and on the medical doctor side. So you can get a job in pharma being somebody who discovers drugs. Some other things that you can do. You can actually be an ecologist, and you could look at how chemicals in plants defend those plants from, say, insects or from rabbits or deer that want to eat them. So you can be a chemist, you can be a pharmacologist, you can be an ecologist. You could also be involved in dietary supplements. So a lot of the compounds that come from plants and that come from other natural sources are very good for us in our diets. And so you might be interested in, say, how herbal supplements, how plants that are rich in antioxidants or polyphenols, maybe you've heard that term before, polyphenol, how those sources can affect us in our diet. So you can even be into nutrition, and you can be into health or cosmetics even. So it's really, really broad. There are a ton of jobs in this field. And I think it's been around, this field's been around for hundreds of years, and I think it'll be here for hundreds of years more. But that's a wonderful question, and thank you for it. So that's what a great question. So to clarify, the molecule that we extracted is not a currently used drug. It's something that we hope could be a drug one day. What does this molecule do? We think that it will act as an anti-inflammatory. So when you are having a headache or you have hurt your knee and you get an inflammatory response, this molecule has shown some ability to reduce that inflammatory response. So we're hoping that it can become an anti-inflammatory. But I should stress that this is not a clinical drug. But clinical drugs that come from natural sources are isolated in the exact same way. And thank you for that question. That's another great question. Any more questions? These are great questions. I could sit here all day and answer them, so don't be shy. And I always say, when you're asking a question, there's a really good chance that somebody else has the same question. Well, thank you, everyone. I had a wonderful time today. I hope we learned something. And if you have any questions, please email me or contact me in the College of Pharmacy. Again, my name is Matt Bertin, and everybody have a great day.